Welcome to Sleepy Science. If you enjoy calm knowledge before sleep, please like this video, subscribe to the channel, and write in the comments where you are watching from. Here we explore the universe slowly, gently, and clearly, letting real science flow like a quiet river through the mind. The Milky Way is the home of our sun, our Earth, and every night sky we have ever seen. It is a barred spiral galaxy with a diameter of about 100,000 light years and a thickness of roughly 1,000 light years in its disk. Inside it exist hundreds of billions of stars along with planets, moons, comets, dust clouds, magnetic fields, and invisible matter that shapes everything through gravity. When you look up at the pale glowing band crossing the sky, you are seeing the dense central plane of this enormous structure from the inside. Ancient civilizations thought it was milk spilled across the heavens, but in reality, it is a crowded river of distant suns whose combined light reaches your eyes after traveling for thousands or even millions of years. Our galaxy is organized into several main components. At the center lies a dense bulge filled with old red stars orbiting a supermassive black hole called Sagittarius, with a mass of about 4 million suns. Surrounding this bulge is the flat rotating disk, where spiral arms form sweeping patterns of gas and stars. These arms are not solid structures but waves of density moving through the disk, compressing gas and triggering star formation as they pass. The sun resides in a small spur between two major arms called the Perseus arm and the Sagittarius arm, at a distance of about 26,000 light years from the galactic center. One complete orbit around the center takes our solar system about 220 million years, which means since dinosaurs walked the Earth, we have not even completed a single galactic year. Beyond the bright disk stretches a vast halo made of ancient stars, globular clusters, and dark matter. This halo extends far beyond what the eye can see and contains most of the galaxy's mass in invisible form. Dark matter does not emit or absorb light, yet its gravitational pull holds the galaxy together and controls the speed at which stars orbit. Without it, the Milky Way would fly apart. Scattered through the halo are more than 100 globular clusters, each a tightly bound sphere of hundreds of thousands of stars born in the earliest epochs of the galaxy. These clusters act like fossils, preserving the chemical memory of the young universe and telling astronomers how the Milky Way assembled itself through mergers with smaller galaxies over billions of years. Every star in the Milky Way carries a story written in light and motion. Young blue stars shine briefly and die in powerful explosions that seed space with heavy elements. Older red stars glow steadily for trillions of years, providing long-term stability. Between them drift immense molecular clouds, cold and dark, where new suns are born. In these regions, gravity slowly gathers gas into dense knots that heat ignite and begin nuclear fusion. Planets emerge from swirling disks around these newborn stars using the same atoms once forged in ancient supernova. The calcium in your bones, the iron in your blood, and the oxygen in your breath were all created in stars within this galaxy long before the Earth existed. The Milky Way is not just a place in space. It is a vast living system that continuously recycles matter through birth, transformation, and quiet decay, shaping every world within it. At the heart of the Milky Way lies a region of extreme density, motion, and energy. A place hidden from human eyes by thick curtains of dust, yet revealed through radio, infrared, and X-ray light. This central zone spans only a few thousand light years, yet contains tens of billions of stars packed so tightly that the night sky from any planet there would glow constantly without true darkness. Stars orbit in complex paths influenced by intense gravity and frequent interactions. At the very core rests Sagittarius, a supermassive black hole with a mass equal to about 4 million suns. It is not a giant vacuum cleaner, but a compact object smaller than the orbit of Mercury, yet powerful enough to control the movement of stars far beyond its immediate surroundings. Astronomers track individual stars racing around this invisible center at speeds of thousands of kilometers per second. Their orbits reveal the presence and mass of the black hole with extraordinary precision. Some of these stars complete a full orbit in only a few decades, meaning within a human lifetime, their entire path can be observed. When gas clouds wander too close, they are stretched, heated, and partially consumed, releasing bursts of radiation that echo across the galaxy. Despite its power, Sagittarius A is currently quiet compared to the raging black holes in active galaxies. Long ago, the Milky Way may have shone as a bright quasar visible across the universe, fueled by massive inflows of gas. Traces of that ancient activity remain in giant bubbles of energetic particles extending above and below the galactic plane like silent monuments to a more violent era. Surrounding the black hole is a dense nuclear star cluster filled with massive young stars that challenge traditional models of star formation. In such extreme gravitational and radiative environments, ordinary gas clouds should be torn apart, yet somehow stars still emerge. Their existence suggests that the center of the galaxy operates under different physical rules, where tidal forces, magnetic fields, and shock waves sculpt matter in unusual ways. This region is also rich in exotic objects, neutron stars, pulsars, and stellar mass black holes, drifting unseen yet detectable through brief flashes and gravitational effects. Each one is the collapsed core of a once massive star that lived fast and died young near the galactic core. The bulge around this nucleus is composed mostly of old metal-rich stars that formed during the early assembly of the Milky Way. Their motions are random rather than neatly circular, showing that the bulge was shaped by ancient mergers and internal instabilities. Chemical analysis of their light reveals the rapid pace of early star formation when the galaxy was young and chaotic. Heavy elements appear in high abundance, indicating that multiple generations of stars lived and died quickly, enriching the region with complex atoms. This chemical fingerprint allows astronomers to reconstruct the timeline of galactic growth and understand how the Milky Way transitioned from a turbulent cloud into the graceful spiral we inhabit today. Although distant and hidden, a galactic center influences every orbit, every star, and every future event in the Milky Way. It anchors the rotating disk, guides the flow of gas, and defines the rhythm of our cosmic home. Even from our quiet location, far from its glare, the sun is bound to this center, traveling endlessly through space as part of a vast rotating system. The calm night sky above is connected to that restless heart by gravity and time, linking our small world to a structure of unimaginable scale and age. The spiral arms of the Milky Way are among its most beautiful and misunderstood features. They are not fixed structures made of the same stars forever bound together. Instead, they are moving patterns of higher density, like slow waves traveling through the galactic disk. As these waves pass through clouds of gas, they compress them, triggering the birth of new stars. This is why spiral arms glow with bright blue giants, pink nebulae, and clusters of young suns. They are the nurseries of the galaxy, the places where matter awakens into light. The Milky Way contains several major arms, including the Perseus arm, the Sagittarius arm, the Scutum Centaurus arm, and the Norma arm. Between them lie smaller spurs and bridges of stars and gas. Our solar system rests in one of these quieter regions called the Orion Spur, a gentle branch between two massive arms. From here, the galaxy appears as a soft band in the night sky, because we look along the crowded plane of the disk. Dust within these arms absorbs visible light, hiding much of their true structure from human eyes. Only through radio waves and infrared surveys can astronomers map their full form, tracing hydrogen clouds, carbon monoxide emissions, and star forming regions across tens of thousands of light years. Within the arms, enormous molecular clouds drift like dark oceans in space. Each can contain the mass of millions of suns spread across vast, cold volumes. Inside them, gravity slowly gathers matter into dense cores that collapse and ignite. New stars flare into existence, heating their surroundings, carving glowing cavities in the clouds. Stellar winds and radiation sculpt pillars, arches, and shells that span light years. Over time, the most massive stars exhaust their fuel and explode as supernovae, releasing shock waves that compress nearby gas and seed the region with it. Heavy elements. In this way, each generation of stars prepares the ground for the next, continuing a cycle that has persisted for billions of years. As stars age, they drift away from their birthplaces. The spiral wave moves on, while older stars spread throughout the disk, forming a calmer background of yellow and red light. The Sun itself was born in one such cloud about 4.5 billion years ago, likely alongside thousands of sibling stars now scattered across the galaxy. Some may still exist, moving through space unaware of their shared origin. This slow migration means that the Milky Way is constantly mixing its contents, blending materials from different regions and eras. The arms also host vast magnetic fields, cosmic rays, and turbulent flows that influence the behavior of gas and the formation of planets. They act as engines of change, maintaining the dynamic character of the galaxy. Without them, star birth would slow, the disk would fade, and the Milky Way would become a quiet, aging system. Instead, it remains active, luminous, and evolving. Every glowing nebula visible through a telescope is a sign of this ongoing renewal, a gentle reminder that even on cosmic scales, creation is a continuous process unfolding in silence and light. The galactic disk is the wide rotating plane that gives the Milky Way its familiar spiral form. It is a vast flattened system, stretching nearly 100,000 light years from edge to edge, yet only about 1,000 light years thick. Within this thin layer exist most of the galaxy's stars, gas clouds, nebulae, and planetary systems. Everything visible in the night sky belongs to this disk. Our sun drifts quietly inside it, moving at about 220 kilometers per second, around the galactic center, bound by gravity to a structure so large that its full shape can never be seen from within. The disk is not uniform. It is layered and complex. Near the central regions, stars are densely packed and rich in heavy elements forged through countless stellar generations. Farther out, the density thins and stars become older and poorer in metals. This gradient tells the story of how the Milky Way grew from the inside outward. Gas flowed inward in early epochs, forming stars rapidly near the center, while the outer regions developed more slowly over time. By studying the chemical composition of stars at different distances, astronomers can read this history like rings in a tree. Embedded within the disk are vast lanes of interstellar dust that absorb starlight and divide the galaxy into luminous bands and dark rifts. These dust grains are microscopic fragments of carbon, silicon, and ice, yet together they shape the entire appearance of the Milky Way. They block visible light, but allow infrared radiation to pass, enabling astronomers to peer through them and reveal hidden star-forming regions. Within these shadowed corridors lie cold clouds where temperatures fall to only a few degrees above absolute zero, creating the quiet conditions needed for gravity to begin its work. The disk is in constant motion. Stars follow nearly circular orbits, yet each one also oscillates gently above and below the galactic plane, like a slow breathing rhythm. Over millions of years, These vertical waves create ripples in the structure of the disk. Some are caused by interactions with satellite galaxies that pass nearby, tugging on the Milky Way's mass and leaving subtle distortions behind. Even now, smaller galaxies continue to fall inward, merging with the disk and adding their stars to its flow. Every planetary system, including our own, is a temporary pattern within this rotating ocean of matter. The Earth has circled the galactic center only about 20 times since it formed. During that journey, the Sun has passed through spiral arms regions of intense star formation and calmer inter-arm spaces. Each passage may have influenced the environment of the solar system, altering radiation levels, comet activity, and the broader cosmic neighborhood. The galactic disk is therefore not just a background stage, but an active participant in the long story of life and matter. Seen from afar, the Milky Way's disk would glow softly with billions of overlapping suns. From within, it appears as a pale river of light across the night sky. This is the view shared by every civilization that has ever looked upward. A reminder that our world is not isolated but carried endlessly through space as part of a rotating luminous system older than any mountain, ocean, or species that has ever existed. Every point of light in the Milky Way is a sun with its own mass, temperature, color, lifespan, and story. Together, these stars form a living archive of the galaxy's past. Astronomers divide them into broad populations based on age, composition, and motion. The oldest stars belong to the halo and bulge, carrying very little heavy elements. They formed when the universe itself was young, before many generations of stellar death had enriched space. Younger stars fill the disk, glowing with higher metal content, evidence of billions of years of recycling. By reading the light of stars, scientists can determine not only what they are, but when and where they were born. Mass defines a star's fate. The smallest red dwarfs burn slowly for trillions of years, barely changing across cosmic time. They are the most common stars in the galaxy, yet too faint to see with the naked eye. Sun-like stars live for billions of years, providing long, stable periods for planetary systems to evolve. Massive blue giants blaze intensely for only a few million years before collapsing in violent supernova explosions. Though rare, these giants shape the galaxy through energy and chemistry, forging elements like iron, gold, and uranium, and scattering them across interstellar space. Star clusters reveal how stars are born. Open clusters in the disk contain young stars loosely bound, destined to disperse over time. Globular clusters in the halo are ancient, dense, and stable, surviving for over 12 billion years. Each cluster is a snapshot of a single moment in galactic history. By comparing them, astronomers trace how star formation rates rose and fell, and how the Milky Way assembled itself from smaller fragments. Motion also tells a story. Disk stars orbit smoothly in the same general direction. Halo stars move in elongated, tilted paths, crossing the disk like ghosts from ancient mergers. Some travel backward relative to the galaxy's rotation, evidence that they were once part of smaller galaxies absorbed long ago. The Milky Way is therefore not a single creation, but a mosaic built through time. Streams of stars still arc across the sky, remnants of broken companions, slowly dissolving into the larger whole. Each star is both an individual and a cell within a much larger organism. Their collective gravity shapes the disk, their radiation heats, gas their deaths, enrich space. Without this continuous stellar activity, the galaxy would fade into darkness. Instead, it remains dynamic, layered, and alive. When we look up, we are not seeing random points, but members of a vast interconnected system moving together through space, bound by gravity and time, carrying within them the history of the cosmos itself. Between the stars lies a vast invisible ocean known as the interstellar medium. It is composed of gas, dust, magnetic fields, and high-energy particles spread thinly across the galaxy. Though almost empty by earthly standards, this medium contains enough material to form billions of new stars. It is the substance from which suns are born and into which they eventually return their matter. Every atom in your body once drifted through this quiet space. Most of the interstellar gas is hydrogen, the simplest and most abundant element in the universe. It exists in different states. In some regions it is hot and ionized, glowing faintly in radio waves. In others, it is cool and neutral, forming extended clouds that trace the spiral arms. The coldest portions gather into molecular form where temperatures fall low enough for hydrogen atoms to bond. These molecular clouds are the true cradles of star formation. They appear dark against the bright background of the Milky Way, absorbing starlight and hiding complex internal structures. Dust grains, though tiny, play an outsized role. They shield molecules from destructive radiation, allow chemical reactions on their surfaces, and help clouds cool and collapse. They also sculpt the galaxy's appearance, creating dark lanes and glowing nebulae. When illuminated by nearby stars, dust scatters light, producing soft blue reflections or warm red glows depending on conditions. These clouds become canvases painted by stellar energy, forming shapes that stretch across light years. The interstellar medium is in constant motion, driven by stellar winds, supernova shock waves, galactic rotation, and magnetic forces. Bubbles and shells expand where massive stars once lived. Filaments twist under magnetic tension. Turbulence ripples through clouds like slow storms in space. Over millions of years, this motion gathers matter into dense knots. Gravity then takes over, beginning the long, quiet collapse that ends in ignition. This medium is also a chemical laboratory. Simple atoms combine into molecules such as water, carbon monoxide, ammonia, and complex organic compounds. Some of these drift into forming planetary systems, becoming part of comets, oceans, and atmospheres. The ingredients for life are therefore not rare accidents, but natural products of galactic processes. The Milky Way breathes through this medium. Stars form from it, shine and return material through winds and explosions. That enriched matter mixes back into clouds, beginning the cycle again. The galaxy is sustained by this slow exchange, a continuous circulation between light and darkness. In this way, the space between stars is not empty, but fertile, a silent reservoir of future worlds and future suns. Star formation is the quiet engine that keeps the Milky Way alive. It begins inside the coldest and darkest regions of molecular clouds, where gravity slowly overcomes internal motion. These clouds are enormous, spanning tens to hundreds of light years, yet within them tiny dense cores emerge almost invisibly. Over thousands of years, matter drifts inward, temperature rises, and a protostar forms at the center. At first, it is only a warm, glowing sphere hidden by thick dust, but as mass increases, pressure in the core grows until nuclear fusion ignites. Hydrogen begins to merge into helium, releasing energy, and a true star is born. Around this newborn sun, a rotating disk of gas and dust remains. Inside that disk, particles collide, stick and grow into pebbles, rocks, and eventually planetary bodies. This is how solar systems form, not as rare miracles, but as natural byproducts of star birth. Observations across the Milky Way show thousands of such disks glowing faintly in infrared light. Some are thin and orderly, others turbulent and warped, shaped by nearby stars and magnetic fields. Each one is a potential birthplace for worlds. Mass determines everything. Small protostars become red dwarfs, burning slowly for immense spans of time. Larger ones become sun-like stars, with stable lives measured in billions of years. The most massive ignite, violently emitting intense radiation that sculpts their surroundings. Their light erodes nearby clouds, halting further collapse in some areas while triggering it in others. This feedback regulates star formation across the galaxy, preventing clouds from turning entirely into stars at once. Stars are rarely born alone. Most emerge in clusters containing dozens, hundreds, or thousands of siblings. These clusters drift apart over time, releasing stars into the galactic disk. The Sun itself likely formed in such a group. Evidence in meteorites suggests nearby supernova explosions enriched the early solar system with heavy elements. Long-lost siblings of the Sun now travel the Milky Way, silently sharing a common origin without awareness. Star birth is therefore both local and galactic. Each individual cloud responds to gravity and turbulence, yet the overall rate is controlled by spiral arms feedback and the flow of gas through the disk. The Milky Way forms only a few new stars each year, a gentle, steady pace that has continued for billions of years. This slow rhythm ensures continuity. The galaxy does not blaze itself out in a single burst, but renews itself gradually, maintaining light across cosmic time. Every star carries within it the promise of an ending. That ending depends on mass and determines how the galaxy evolves. Small red dwarfs will fade slowly, for trillions of years, never exploding, never dramatically changing their surroundings. Sun-like stars expand into red giants, shedding their outer layers into space and leaving behind dense white dwarf cores. These ejected shells form planetary nebulae, delicate glowing bubbles that drift outward, enriching the interstellar medium with carbon, oxygen, and nitrogen. Massive stars meet a far more violent fate. After burning through their nuclear fuel, they collapse in a fraction of a second. Their cores rebound in titanic supernova explosions that briefly outshine entire galaxies. In these moments, extreme temperatures and pressures forge the heaviest elements in nature. Gold, platinum, uranium, and many others are created only in such cataclysms. The blast waves race outward, compressing nearby gas, triggering new star formation, while scattering enriched material across light years. The remnants of these deaths are extraordinary objects. Neutron stars pack more mass than the Sun into a sphere the size of a city. Their gravity is so intense that a teaspoon of their matter would weigh billions of tons. Some spin rapidly, emitting beams of radiation observed as pulsars, precise cosmic clocks visible across the galaxy. Others collapse further into black holes, invisible except for their gravitational influence. These compact remnants populate the Milky Way, silently shaping the motion of nearby stars and gas. Supernova remnants expand as vast glowing shells visible in radio-optical and X-ray light. They mark the locations where stars once lived and died. Over tens of thousands of years, they merge back into the interstellar medium, becoming part of future clouds. In this way, death feeds birth. Each generation of stars increases the chemical complexity of the galaxy, making rocky planets, oceans, and life itself possible. Without stellar death, the Milky Way would remain chemically simple, composed mostly of hydrogen and helium. There would be no iron cores, no silicon rocks, no organic molecules. The galaxy's beauty and diversity arise from this cycle. Creation, destruction, and renewal operate together across timescales far beyond human experience. The calm night sky is therefore the visible surface of a vast ongoing transformation, where every point of light is part of an endless exchange between matter and energy. Around countless stars in the Milky Way lie planetary systems, each shaped by the same physical laws, yet unfolding in endlessly different ways. From the moment a star ignites, its surrounding disk begins to organize. Dust grains collide and grow into larger bodies. Within a few million years, planets emerge, carving paths through the remaining gas. Some systems form tightly packed rocky worlds. Others give rise to massive gas giants drifting in wide cold orbits. Observations reveal planets larger than Jupiter, orbiting closer to their stars than Mercury does to the Sun, and tiny dense worlds made almost entirely of iron. The diversity is immense, and it tells us that our solar system is only one expression among billions. Modern surveys show that most stars host planets. The Milky Way likely contains hundreds of billions of them. Many lie within regions where temperatures allow liquid water to exist on surfaces. These habitable zones depend on stellar type and planetary atmosphere, but they appear around red dwarf sun-like stars and even some larger suns. This means that calm, temperate worlds may be common across the galaxy. Some orbit in stable environments for billions of years, providing long windows for chemical evolution. Planetary systems do not remain fixed. Gravitational interactions cause migration, scattering, and resonance. Giant planets can move inward, disrupting inner worlds or protecting them by deflecting comets. Asteroid belts and comet clouds form as leftovers, shaping impact histories. Over time, these dynamics influence surface conditions, climate, and the potential for life. Even small changes in orbital architecture can transform a world from frozen desert to ocean-covered haven. The materials that build planets come from stellar generations before them. Silicates, metals, and water are gifts from ancient supernovae and dying stars. Every rocky surface, every ocean basin and mountain range is therefore a product of galactic history. Planets are the Milky Way's way of giving structure to stardust. From afar, planetary systems are invisible. They are detected through subtle wobbles, dimming starlight, and faint infrared glows. Yet they may be the most significant structures in the galaxy, for they provide places where chemistry becomes complexity and matter gains memory. Each world is a small island in a vast cosmic sea. Together, they transform the Milky Way from a collection of stars into a realm of potential stories, some perhaps unfolding quietly even now under distant alien skies. The Milky Way does not exist alone in space. It is surrounded by dozens of smaller companion galaxies drifting through the same region of the universe. The largest of these are the Large Magellanic Cloud and the Small Magellanic Cloud, two irregular galaxies visible from the southern hemisphere as soft, luminous patches. They orbit our galaxy bound by gravity, trailing streams of gas and stars behind them like cosmic footprints. These streams reveal that the Milky Way is slowly drawing in its neighbors, growing through quiet absorption. Over billions of years, the galaxy has merged with many such companions. Each merger leaves subtle signatures in the motions and compositions of stars. Long arcs of stellar streams still wrap around the Milky Way, remnants of ancient galaxies torn apart and stretched by gravity. These stars move together, sharing similar chemical fingerprints that betray their common origin. By mapping these streams, astronomers reconstruct the history of galactic assembly, revealing that our home is a mosaic built from many smaller systems. Mergers reshape structure. They thicken the disk, stir the halo, and feed the central regions with gas. Some may have triggered bursts of star formation, lighting the galaxy more brightly in the past. Others deposited globular clusters and exotic stars into wide orbits. The calm spiral we see today is therefore the product of long interaction, not isolation. Far beyond the visible disk, the gravitational influence of the Milky Way extends hundreds of thousands of light years. Dark matter forms an enormous halo that captures passing systems, guiding them inward. This invisible mass controls the choreography of the local group, the small collection of galaxies that includes Andromeda and Triangulum. Even now, Andromeda is moving toward us. In about 4 billion years, the two spirals will merge, forming a new giant galaxy. Stars will rarely collide, but their orbits will change dramatically, reshaping the sky of every world. Galaxies grow like living organisms through accumulation and transformation. The Milky Way's current form is only a phase in a much longer evolution. Its spiral arms, its disk, and its halo are temporary arrangements in an ongoing process of gravitational sculpture. Every star in the night sky carries the imprint of ancient encounters and future change. Our galaxy is not a finished object, but a river of matter flowing through time, gathering, shaping, and redistributing itself across the universe. Beyond the bright disk and glowing arms of the Milky Way lies a vast and almost invisible realm known as the galactic halo. It surrounds the galaxy like a silent ocean extending hundreds of thousands of light years into space. Here stars are sparse, distances are immense, and darkness dominates. Yet this region holds deep clues about the earliest chapters of our galaxy's life. The halo contains some of the oldest stars in existence. These stars formed more than 12 billion years ago, when the Milky Way was still assembling from primordial gas and merging fragments. They are poor in heavy elements, carrying chemical signatures from a universe that had not yet been enriched by many generations of stellar death. Their light is faint and reddish, their motions slow and elliptical. They orbit the galaxy in tilted paths, passing through the disk like ancient travelers from another era. Scattered throughout the halo are globular clusters, dense spherical collections of hundreds of thousands of stars. Each cluster is a relic from the early universe. They are tightly bound and remarkably stable, surviving nearly unchanged across cosmic time. Within them, stars are packed so closely that from any planet inside the sky would blaze with light. These clusters orbit far from the galactic plane, acting as time capsules, preserving the conditions of early star formation. The halo is also where dark matter dominates. Though invisible, it outweighs all visible matter in the galaxy. The gravitational pull holds the Milky Way together, controlling how fast stars move and how far the disk extends. Without this hidden mass, the galaxy would not be stable. Stars in the outer regions would escape into intergalactic space. Instead, they remain bound, moving in harmony with an unseen structure that shapes everything. Streams of stars weave through the halo. They are the remains of dwarf galaxies torn apart by gravity. These streams trace elegant arcs across the sky, revealing ongoing accretion. The Milky Way is still growing. Even now, small systems continue to fall inward, adding their stars to the halo and disk. The galaxy breathes in its surroundings, slowly expanding its reach. The halo may appear empty, but it is foundational. It is the memory of the galaxy's youth and the framework of its present. Every orbit within the disk is guided by the mass of this unseen realm. In silence and darkness, it governs the luminous heart. The calm night sky we know is suspended within this vast invisible architecture, reminding us that much of reality lies beyond direct sight, yet shapes every motion we observe. Much of the Milky Way is not made of stars, gas, or dust, but of something unseen. Dark matter does not shine, reflect, or absorb light, yet its presence is revealed through gravity. When astronomers measure how fast stars orbit the galactic center, they find that visible matter alone cannot explain their motion. Outer stars move far too quickly. Without an additional hidden mass, the galaxy would tear itself apart. Dark matter provides that missing gravity, forming an immense halo that envelops the Milky Way and extends far beyond the visible disk. This invisible structure is older than the galaxy itself. In the early universe, tiny fluctuations in dark matter density grew under gravity, forming vast webs across space. Ordinary matter flowed into these wells, gathering and cooling until stars and galaxies ignited. The Milky Way formed inside one such dark matter halo. Every spiral arm, every star cluster, and every planetary system exists because this hidden scaffold shaped the flow of matter. Although dark matter does not interact with light, it may consist of unknown particles that rarely interact with normal atoms. Experiments deep underground search for faint signals of these particles passing through Earth. Telescopes study subtle gravitational lensing where dark matter bends the light of distant galaxies, revealing its distribution. Computer simulations show that without dark matter, the universe would be smooth and nearly empty. With its structure emerges, galaxies form. Complexity becomes possible. Within the Milky Way, dark matter governs the long-term stability of the disk. It cushions the effects of mergers, absorbs momentum, and keeps stars bound. It determines how far spiral arms reach and how satellite galaxies orbit. Even the future collision with Andromeda will be shaped by the interaction of two enormous dark matter halos merging long before the visible galaxies. fully intertwine. Though unseen, dark matter is a constant presence. It flows through every region, including the space around the Sun and Earth. Each second, countless dark matter particles may pass through your body without effect. You are moving inside a vast, invisible ocean that connects you gravitationally to the edge of the galaxy. The Milky Way is therefore more than what appears in the night sky. Light reveals only a thin, luminous skin. Beneath it lies a deep, hidden framework holding everything in place. Understanding this invisible component transforms the galaxy from a collection of stars into a complex system shaped by forces beyond direct perception. It reminds us that the universe is richer than sight alone, and that much of reality exists quietly guiding every motion in silence. Nothing in the Milky Way is still. Every star, every cloud, and every world is in motion, carried along by gravity through immense spans of space. The entire galaxy rotates like a slow, majestic wheel. Near the center, stars complete their orbits in tens of millions of years, while in the outer regions, a single revolution can take more than 400 million years. The Sun moves in a nearly circular path around the galactic core at about 220 kilometers per second. Even in complete stillness on Earth, you are traveling through space at astonishing speed, bound to a star that is bound to a galaxy that is bound to a cluster of galaxies drifting through the expanding universe. This motion is not perfectly smooth. Stars gently oscillate above and below the galactic plane, like waves on a vast ocean. Some drift inward or outward over time, influenced by spiral arms passing encounters with clouds and the pull of nearby stars. Over billions of years, this slow wandering mixes the contents of the disk, blending populations born in different eras and places. The Milky Way becomes a great archive in motion where matter from distant regions eventually meets and merges. Time in the galaxy flows on scales far beyond human intuition. Civilizations rise and fall in moments compared to the orbit of a star around the center. Mountains erode, oceans shift, and species evolve, while the Sun advances only a tiny fraction along its path. The galaxy remembers through chemistry and motion. The age of a star can be read from its light. The history of a merger can be traced in stellar streams. Even ancient explosions leave expanding shells that persist for tens of thousands of years. Some events are sudden supernovae, gamma-ray bursts, close encounters between stars in dense regions. Others are so slow they feel eternal, such as the gradual collapse of a molecular cloud, or the migration of stars through the disk. Together they create a layered tempo, fast flashes embedded within deep cosmic rhythms. To exist within the Milky Way is to be part of a long journey. The atoms in your body have traveled through ancient stars, across clouds, through darkness and fire. They have waited in silence for millions of years before becoming part of a living world. You are not standing still in space. You are moving with a galaxy across time, carried by forces older than Earth itself. The calm of the night sky hides this vast motion, reminding us that stillness and movement can exist together, that beneath quiet light flows an endless cosmic current. The Milky Way is filled not only with stars and clouds, but with energy moving silently through space. Radiation flows from every sun in the form of light, heat, and charged particles. Magnetic fields thread the disk, guiding this energy, shaping clouds and influencing how matter moves. Cosmic rays born in supernova explosions race across the galaxy at near light speed, carrying the imprint of violent events that happened long before Earth existed. This invisible environment surrounds every world, bathing planets in a constant background of energy. Near massive stars, radiation is intense. Ultraviolet light strips electrons from atoms, heating gas and carving glowing cavities in nebulae. Stellar winds stream outward, pushing matter and compressing nearby regions. These forces determine where new stars can form and where clouds are dispersed. In calmer regions like the neighborhood of the sun, radiation is gentle enough to allow stable planetary climates. This balance between energetic and quiet zones defines the habitability of different parts of the galaxy. Supernovae periodically flood their surroundings with shock waves and high-energy particles. In dense regions, these explosions can sterilize nearby planets, stripping atmospheres and damaging complex chemistry. Yet, they are also essential. They create heavy elements, stir clouds, and trigger new star birth. The same event that ends one stellar life can begin dozens more. The galaxy maintains itself through this exchange between hazard and creation. The Milky Way also contains large-scale structures of energy, such as enormous bubbles rising above and below the disk, remnants of ancient outbursts. From the central black hole, these structures stretch tens of thousands of light-years, carrying hot plasma into the halo. They show that even in its current calm state, the galaxy remembers periods of far greater activity. Every planetary system exists within this broader galactic climate. Long-term stability depends not only on its star, but on its position within the disk, its distance from energetic regions, and the timing of nearby explosions. Life-friendly environments may therefore cluster in certain zones where radiation levels are moderate and catastrophic events are rare. Some scientists call this the galactic habitable zone, a region where heavy elements are abundant but destructive forces are less frequent. The Milky Way is not merely a collection of objects. It is an active, energetic medium where light fields and particles connect distant regions. Even in deep space, far from any star, faint radiation persists, a whisper of countless suns. Within this quiet glow, worlds evolve, chemistry unfolds, and time flows. The galaxy becomes not just a structure, but an environment, a vast cosmic landscape in which every planet drifts through fields of energy shaped by ancient events and ongoing motion. Within the immense scale of the Milky Way, the emergence of life may seem small, yet it is one of the most profound expressions of galactic evolution. Life is not separate from the galaxy, but a direct consequence of its processes. Every element required for biology, carbon, oxygen, nitrogen, phosphorus, iron, was forged in stars and distributed through supernovae and stellar winds. The galaxy acts as a vast factory, creating the raw materials for chemistry and then delivering them into forming planetary systems. Without billions of years of stellar birth and death, there could be no oceans, no rocks, no cells, and no minds to wonder. The Milky Way contains countless worlds where conditions may resemble those of early Earth. Planets orbit in temperate zones around long-lived stars. Some possess water-rich surfaces, thick atmospheres, and stable climates. Others hide oceans beneath icy shells warmed by internal heat. Chemistry unfolds wherever energy meets complexity. In such places, molecules can organize, replicate, and evolve. Life may arise quietly, as it did here, beginning with simple structures and slowly building diversity over immense spans of time. Yet the galaxy is not uniformly gentle. Nearby supernovae, intense radiation, and gravitational disturbances can interrupt or reset biological progress. Entire biospheres may vanish before reaching complexity. Others may endure for billions of years under steady light. The distribution of life therefore depends on both chance and environment. Regions with frequent massive star formation may be too violent. Regions lacking heavy elements may not form rocky worlds. Between these extremes lie broad zones of possibility. If life exists elsewhere in the Milky Way, it would share a common heritage of atoms and physics. Its biochemistry may differ, yet its foundation would be the same cosmic material, shaped by the same forces. Every living system would be a local expression of a galactic process. The galaxy would not merely host life, it would generate it. From this perspective, Earth is not unique in principle, but in history. It is one successful outcome among countless experiments carried out by the Milky Way over billions of years. Each star system is a laboratory, each planet a potential story. Some remain barren, some bloom briefly, some may grow civilizations that look up at their own skies and wonder. Life is therefore the Milky Way becoming aware of itself in fragments. Through living worlds, the galaxy gains memory, perception, and meaning. Atoms that once drifted in darkness now think, feel, and observe. In this sense, every conscious being is a small awakening of the galaxy, a moment where cosmic matter pauses to reflect on its own existence. The Milky Way is ancient, yet it is still young compared to what lies ahead. Stars will continue to form for billions of years as long as gas remains in the disk. Red dwarfs will shine far beyond the lifetime of the sun. The galaxy will slowly change its shape, its brightness, and its rhythm. Spiral arms will drift and reform. Clouds will collapse. New suns will rise in quiet darkness. The night sky of distant future worlds will not be the same as ours, yet the same forces will guide it. The most dramatic transformation will occur when the Milky Way and the Andromeda Galaxy finally meet. They are already moving toward one another at more than 100 kilometers per second. In roughly 4 billion years, their dark matter halos will merge first, followed by long tidal streams of stars stretching across space. Over time, the two great spirals will interweave. Disks will warp, data. Arms will dissolve. New bursts of star formation will ignite as gas clouds collide and compress. Despite the scale of this event, individual stars will rarely collide. The distances between them are vast. Instead, their orbits will change. The sun or its distant descendants may be flung into a new region of the merged system. The night sky from any surviving world will transform as foreign stars flood the heavens and old constellations fade. After several billion years, the chaotic structure will settle into a single massive elliptical galaxy, often called Milkomeda by astronomers. Within that future galaxy, star formation will gradually slow as gas is consumed or heated. The bright blue stars will become rare. The light of the system will grow redder, dominated by long-lived dwarfs and aging giants. Over trillions of years, even these will fade. The universe itself will continue to expand, carrying galaxies farther apart. The Milky Way's descendants will become an island of light in a growing sea of darkness. Yet even this is not an end, but a continuation. Matter will remain. Motion will persist. Atoms will still drift and combine. Long after the sun is gone, long after Earth is dust, the galaxy will still exist in altered form, carrying forward the same materials that once shaped oceans, forests, and mines. The Milky Way is therefore not only a place of origin, but a vessel of continuity. It carries the story of matter across time, linking past and future in a single immense journey through space. Human history is measured in thousands of years, yet the Milky Way measures time in billions. Still, humanity is not separate from this vast system. Every movement of Earth, every season, and every generation unfolds, while the sun travels its endless path around the galactic center. The sky that ancient people watched is part of the same structure we study today. The myths of a glowing river across the night were early human attempts to understand a truth far larger than any culture. Modern science has transformed that wonder into knowledge. We now know our position in the Orion Spur, our distance from the center, and the nature of the stars above. Telescopes map clouds and arms. Space probes carry human instruments beyond the solar system, sensing the local interstellar medium. Radio waves from Earth travel outward, becoming faint whispers drifting through the disk. Humanity has begun to touch the galactic environment in a physical way. Yet even with this progress, we remain deeply local. We have explored only a tiny neighborhood around the sun. The nearest star lies more than 4 light years away. Most of the Milky Way remains forever unreachable by any practical travel. Our connection to it is therefore primarily through light and understanding. We know distant regions because photons have crossed tens of thousands of light years to reach our instruments. We reconstruct ancient events by reading spectral lines and motions. Knowledge becomes our way of moving through the galaxy. The Milky Way shapes human destiny in subtle ways. The stability of our orbit, the relative calm of our region, the absence of frequent nearby supernovae, all contributed to long, uninterrupted biological evolution. The quiet environment of our galactic neighborhood allowed complex life to develop without repeated cosmic catastrophe. In this sense, the position of the sun within the galaxy is part of the reason humanity exists. As technology grows, humans may one day spread to nearby stars. Even then, each step will remain within the same galactic home. Every future colony, every distant outpost will still orbit the same center and share the same dark matter halo. Humanity will not leave the Milky Way in any meaningful sense. It will simply explore different rooms within it. To know the galaxy is therefore to know our larger context. Earth is not an isolated stage. It is a moving platform carried by a star, carried by a spiral arm, carried by a vast rotating system older than any life. Human thought emerges from this motion. Every idea, every dream, and every story is shaped by atoms forged in ancient suns. In understanding the Milky Way, humanity understands itself not as a visitor in the universe, but as one of its natural expressions. For most of human history, the Milky Way was not an abstract concept, but a visible presence stretching across the darkness. Far from city lights, it appears as a luminous river made of countless unresolved stars. This sight is not a symbol or illusion. It is a direct view into the structure that holds our world. When you look at that pale band, you are looking through the disk of the galaxy across tens of thousands of light years. Every brighter knot is a region rich with stars. Every dark rift is a lane of dust blocking distant light. The night sky is therefore a map of our position. We see more stars toward the galactic center because that direction holds the densest regions. We see fewer toward the anticenter where the disk thins. The plane of the Milky Way marks the flat shape of the galaxy. Even without instruments, ancient observers could sense that the universe had structure. Their stories preserved this intuition long before science gave it form. Telescopes transform this band into depth. What appears as mist becomes countless suns. Dark gaps become immense clouds. Subtle brightness variations reveal spiral arms and star-forming regions. Each improvement in observation peels back another layer. Radio telescopes map hydrogen across the disk. Infrared eyes pierce dust to reveal hidden nurseries. X-ray instruments show the hot remnants of stellar death. Together, they turn the night sky into a three-dimensional landscape. Light carries time. The stars you see are not as they are now, but as they were when their light began its journey. Some have already died. Some have changed. The galaxy you observe is therefore layered with history. The sky is a record of events unfolding across different eras at once. To look up is to see the past distributed across space. This transforms the simple act of watching the stars. It becomes an encounter with the structure and memory of the Milky Way. You are not merely seeing points of light. You are seeing motion, depth, and time combined into a single image. The calm beauty of the night hides an immense dynamic system. In this way, the galaxy is present even in silence. Without knowing equations or distances, anyone can stand under the stars and witness the shape of their cosmic home. The Milky Way does not require belief or imagination. It is already above you every clear night, quietly revealing that Earth is part of something vast, ordered, and enduring. No being inside a forest can see the full shape of the forest. In the same way, no observer within the Milky Way can directly view its complete form. We infer its structure through motion, light, and mathematics. From Earth, we map distances using parallax, measure stellar speeds, and trace gas through radio waves. Piece by piece, a picture emerges of a barred spiral galaxy, with a central bar of stars extending across the core and arms unfolding from its ends. This form is not static. It breathes slowly, changing over hundreds of millions of years. The bar acts as a conveyor of matter. It channels gas inward, feeding the central regions and regulating star formation. It influences the shape of spiral arms and the motion of stars near the core. Many galaxies in the universe display similar bars, showing that this structure is a natural outcome of rotating disks under gravity. The Milky Way is therefore not unique in form, but part of a wider family of spirals, shaped by the same physical principles. Our understanding of this shape comes from indirect vision. We cannot step outside to photograph our galaxy. Instead, we reconstruct it from within like archaeologists rebuilding an ancient city from scattered ruins. Each survey adds detail. Each new wavelength reveals hidden components. The picture remains incomplete yet increasingly refined. This limitation carries meaning. The Milky Way teaches humility. We are embedded within what we seek to understand. Knowledge must be built from fragments and inference. Even so, the structure becomes clear enough to navigate. We know where we are. We know where the center lies. We know the direction of arms and the scale of the disk. The unseen becomes mentally visible. Every civilization that gazes at the night sky shares this position. They too would be inside their own galaxy, unable to see its full form. Intelligence in the universe likely always begins from within. Awareness grows inward before it can ever imagine outward. The Milky Way is thus both our home and our horizon. To live inside a galaxy is to inhabit a structure larger than any direct experience. It is to be part of something that cannot be fully seen yet can be understood. The unseen shape guides every orbit, every star, and every future event. Even without viewing it from outside, you move within its curves, carried by its gravity, shaped by its form. You are always inside the Milky Way, even when unaware, and every moment unfolds within a design written across 100,000 light years. The Milky Way is immense on human scales, yet it is only one member of a vast cosmic population. The observable universe contains hundreds of billions of galaxies, each holding billions or trillions of stars. They are arranged in filaments and clusters, separated by enormous voids, forming a structure often called the cosmic web. Our galaxy belongs to a small group known as the Local Group, along with Andromeda Triangulum and dozens of dwarf galaxies. Together they drift through space, bound by gravity, sharing a common environment shaped by dark matter. From a distant vantage point, the Milky Way would appear as a faint spiral of light among countless others. Its stars would blend into a soft glow. Its individual worlds would be invisible. Yet within that faint pattern exists every human story, every ocean, and every memory. This contrast between internal richness and external smallness defines our cosmic position. The galaxy is both vast to us and tiny to the universe. Galaxies interact across great distances through gravity and radiation. Clusters of thousands of galaxies orbit common centers, merging over time into enormous structures. The Milky Way's future with Andromeda is part of this larger rhythm. Across the universe, similar mergers are unfolding. Spiral galaxies collide, become ellipticals, and eventually fade. The universe evolves through these slow, grand transformations. Light from distant galaxies takes millions or billions of years to reach us. When we observe them, we see the universe as it once was. Some appear in their youth blazing with intense star formation. Others are ancient and quiet. By comparing them with the Milky Way, astronomers place our galaxy in a broader timeline. It is neither among the youngest nor the oldest. It exists in a mature era where heavy elements are abundant and complex structures are common. This context reveals that the Milky Way is not an isolated miracle, but a natural outcome of cosmic evolution. It formed where conditions allowed. It grew through mergers. It shaped itself through rotation and feedback. What makes it special is not its rarity, but our presence within it. The universe is filled with galaxies, each a world of stars and possibilities. The Milky Way is the one that contains Earth. It is the one whose light forms our night sky and whose history formed our atoms. Among the countless spirals drifting through darkness, this single galaxy is home. Through it, the universe becomes local, and through it, the infinite becomes intimate. The Milky Way is not merely a collection of stars scattered in space. It is a coherent system governed by gravity, motion, energy, and time. Every component influences every other. Gas flows along spiral arms, stars heat, surrounding clouds, supernovae reshape regions, dark matter binds the whole. Nothing exists in isolation. Each part participates in a network of cause and effect that spans tens of thousands of light years. A change in one region can echo across the galaxy. A burst of star formation in an arm enriches future clouds. A merger with a small galaxy thickens the disk and alters stellar orbits. An outflow from the central black hole injects energy into the halo. These processes operate on different scales yet remain connected. The Milky Way behaves less like a static object and more like a living structure evolving through interaction. This systemic nature becomes clear through simulation. Modern computers model billions of particles representing stars, gas, and dark matter. Over virtual billions of years, spiral arms emerge, bars form, halos grow, and mergers unfold. These digital galaxies resemble the real one, revealing that complex beauty arises from simple physical laws applied over immense time. Gravity combined with motion is enough to generate order. Energy flows through the system continuously. Nuclear fusion in stars converts mass into light. That light heats gas, drives winds, and powers chemistry. Gravitational potential becomes kinetic motion as stars orbit and clouds collapse. Supernovae convert stored energy into shock waves. The galaxy is therefore a vast engine transforming energy across scales. Balance emerges from this flow. Too much star formation would exhaust gas quickly. Too little would leave the galaxy dim and inert. Feedback maintains a middle path. Massive stars limit further collapse. Radiation regulates density. The Milky Way finds stability not through stillness, but through dynamic equilibrium. To understand the galaxy is to understand relationships rather than isolated objects. A star is defined by its environment. A cloud exists because of past explosions. A planet forms because heavy elements accumulated over generations. Everything is linked. This view transforms perspective. You are not simply on a planet orbiting a star. You are within a galactic system shaped by ancient events. Your existence depends on balance maintained across billions of years and trillions of kilometers. The calm night sky is the visible surface of a vast self-organizing structure. Beneath its quiet glow lies a complex interconnected whole moving steadily through time. Everything we know about the Milky Way comes from light. Stars speak through photons, traveling across space, carrying information about temperature, motion, composition, and age. Each color, each spectral line is a letter in a cosmic language. By spreading starlight into rainbows, astronomers read these messages, discovering what stars are made of, how fast they move, and how long they have lived. The galaxy reveals itself not through touch, but through vibration and glow. Different forms of light uncover different layers. Visible light shows stars and bright nebulae. Infrared penetrates dust, revealing hidden nurseries in the crowded core. Radio waves trace cold hydrogen, outlining spiral arms across the entire disk. X-rays expose violent regions around black holes and supernova remnants. Gamma rays mark the paths of cosmic particles. Each wavelength adds depth, turning a flat sky into a living three-dimensional map. Light also carries motion. Through the Doppler effect, tiny shifts in wavelength reveal whether a star is moving toward or away from us. By measuring these shifts across millions of stars, astronomers reconstruct the rotation of the galaxy. They see how fast different regions turn, how the bar influences motion, and how streams from ancient mergers flow through the halo. The Milky Way becomes not just a picture, but a moving system whose currents can be traced. Distance is written in light as well. Nearby stars shift slightly against distant backgrounds as Earth orbits the Sun. This parallax provides the first steps of a vast, cosmic ladder. Other methods build upon it, using stellar brightness, variable stars, and supernovae to extend measurement across the disk. Through these techniques, the size of the galaxy becomes real, not imagined. 100,000 light-years becomes a measured span rather than an abstract number. The galaxy therefore reveals itself patiently. Phones leave distant regions long before any human exists. They cross space, undisturbed, until they reach an eye or a sensor. In that instant, ancient events become present. A star that exploded thousands of years ago speaks again. A cloud collapsing millions of years ago becomes visible. Observation becomes a meeting across time. To look at the Milky Way is to receive messages sent before memory. The night sky is a continuous broadcast from deep space. Even in silence, the galaxy is speaking. Every point of light is a sentence written in energy. By learning this language, humanity transforms wonder into understanding. The stars remain distant, yet their stories arrive gently, carried by light across the dark. Understanding the Milky Way is not only an intellectual act, but an emotional one. The scale of the galaxy reshapes how time, distance, and importance are felt. When you realize that light needs 100,000 years to cross the structure ordinary, worries lose weight. The galaxy teaches proportion. It places personal moments within a vast moving context. Yet it does not make them meaningless. Instead, it gives them rarity. In a system this large, every conscious experience becomes precious. The Milky Way shows that stability is achieved through slow change. Stars live and die. Arms drift. Clouds form and dissolve. Nothing remains fixed, yet order persists. This mirrors life on smaller scales. Bodies change. Civilizations rise and fade. Meaning is found not in permanence, but in continuity. The galaxy endures because it is allowed to transform. It remains itself through motion. In the same way, identity is preserved through change rather than against it. There is also comfort in knowing that the universe is not chaotic noise, but structured motion. The stars do not wander aimlessly. They follow paths shaped by gravity. The arms are not random streaks, but organized waves. Even dark matter forms coherent halos. The Milky Way demonstrates that complexity can arise from simple rules, and that beauty can emerge without intention. It exists not because it was designed, but because physical laws allow order to grow. For a mind preparing to rest, this perspective is gentle. The galaxy has carried matter for billions of years without urgency. It does not rush. It does not hurry. Its processes unfold slowly beyond stress and deadline. Clouds take millions of years to collapse. Stars burn for billions. Orbits complete over Eris. You are allowed to slow down because the universe itself moves slowly at its deepest level. To imagine the Milky Way is to imagine belonging to something vast and patient. You are not isolated. You are embedded in a structure that existed long before you and will exist long after. Your atoms are travelers that have known stars and will know others. The galaxy is not distant. It is around you. It is within you. Every breath contains matter shaped by its history. In this way, the Milky Way becomes more than an object of study. It becomes a context for being, a reminder that existence is part of a continuous flow across time and space. The calm of the night sky is not emptiness, but presence, a wide expression of an immense system moving steadily, carrying every world, including yours, through the dark. The Milky Way is a memory written in matter. Every region carries the imprint of past events encoded in motion, chemistry, and structure. A star's composition reveals how many generations came before it. A stream of stars marks the path of a long-consumed galaxy. A bubble of hot gas remembers a supernova that ended thousands of years ago. Nothing is ever fully erased. It is transformed and carried forward into new forms. Even planets preserve this memory. The rocks of Earth contain isotopes created in ancient stellar explosions. Meteorites hold grains older than the sun itself, tiny crystals that formed around dying stars before the solar system existed. These grains survived the collapse of a cloud, the ignition of a star, and the birth of worlds. They are physical records of the galaxy's deep past resting now in human hands. On a larger scale, the shape of the Milky Way remembers its growth. The thick disk recalls early turbulent epochs. The halo remembers mergers. The bar reflects internal evolution. The current calm is layered upon ancient chaos. Each era leaves a trace. The galaxy is therefore not just moving through time. It is carrying time within itself. This makes the Milky Way a bridge between eras. It connects the first stars of the universe to future worlds not yet formed. Matter flows from one generation to the next, never truly beginning or ending. The same hydrogen that fueled the first stars now burns in new suns. The same carbon forged in long-dead giants becomes part of living cells. The galaxy is a continuous narrative written without pause. Human memory is fragile, measured in decades. Galactic memory spans billions of years. Yet, they are related. When a mind learns about the Milky Way, it becomes a place where that vast history is reflected. Knowledge becomes a form of memory within matter itself. Through thought, the galaxy remembers itself in a new way. This is not poetry, but continuity. Atoms arranged into brains reflect on the systems that created them. The Milky Way becomes aware of its own structure through countless small minds scattered across one tiny world. In learning the galaxy, you extend its memory into consciousness. Every clear night offers access to this archive. The sky is not empty. It is filled with records traveling at the speed of light. To look up is to read the past. To understand is to participate in a story far older than any life. The Milky Way is not only where you are, it is what made it possible for you to be. The Milky Way is not only a structure of stars and gas, but a true home in the deepest sense. Every particle that forms your body has traveled through this galaxy for billions of years. It has drifted through clouds, burned in stellar cores, been scattered by explosions and cooled in darkness before becoming part of a living world. You are made of the galaxy. The calcium in your bones, the iron in your blood, and the oxygen in your breath are products of ancient stars that lived and died within this same rotating system. There is no boundary between you and the Milky Way. You are one of its temporary shapes. To live inside a galaxy is to be carried by a motion older than memory. The sun moves around the center. Earth moves around the sun. Every heartbeat occurs while you travel through space at immense speed. Yet, this motion feels like stillness. Gravity holds everything in gentle order. The galaxy does not rush. It turns slowly, patiently, allowing worlds to form and evolve. In this calm rhythm, complexity becomes possible. Oceans persist. Life adapts. Minds emerge. Thought itself is a product of galactic stability. The Milky Way teaches that vastness and intimacy can exist together. From afar, it is a faint spiral among billions. From within it is the entire sky. It is large enough to hold countless worlds and quiet enough to let a single planet grow forests and cultures. Its size does not erase meaning. It provides the stage on which meaning can exist. In a universe without galaxies, matter would remain thin and scattered. There would be no long-lived stars, no heavy elements, no solid ground. The Milky Way is the reason there is a place to stand. Every future generation will remain within this same system. Even if humanity spreads to nearby stars, each new world will still orbit the same center and share the same dark halo. Every story will unfold under a sky shaped by the same disk. The galaxy will remain the greater landscape of human existence. It will be present in every night sky, every calendar of stars, every attempt to understand origin and destiny. When you prepare for rest and allow the mind to slow, imagine the galaxy not as distant but as surrounding you. The room you are in is moving through space. The planet beneath you is part of a star. That star is part of a spiral arm. That arm is part of a vast rotating system older than Earth itself. You are safe within it, carried by a structure that has endured for billions of years. The Milky Way does not hurry. It turns quietly through the dark, holding every world in gentle motion, offering a sense of belonging that reaches far beyond any single place. The Milky Way continues even when no one is watching. While cities sleep and oceans breathe in darkness, the galaxy turns. Stars shift by distances too small to notice yet unstoppable across time. Clouds drift. Light travels. Every second adds a new layer to a story that began long before memory. This motion is gentle. It does not announce itself. It simply happens. The universe does not rush. It allows change to unfold slowly so that complexity can arise and remain. Within this slow drift, every life becomes a brief pattern of awareness. A mind opens for a moment in cosmic time, then fades. Yet nothing is wasted. Every thought is a rearrangement of ancient matter. Every breath is a continuation of stellar chemistry. The galaxy does not lose what passes. It transforms it. The atoms of a body return to clouds. Those clouds become new stars. Those stars one day light other worlds. The cycle is not cold. It is patient. There is comfort in belonging to something so large and enduring. The Milky Way has survived impacts, explosions, and mergers. It has absorbed other galaxies and reshaped itself. It will outlive every mountain and every ocean. To be part of it is to be part of a continuity that stretches beyond fear. Individual moments are fragile. The system that carries them is resilient. As you rest, the galaxy does not require attention. It does not need belief. It exists regardless. You're already inside it. You do not have to travel anywhere to reach it. The floor beneath you is moving through space. The sky above is a map of your surroundings. Even with eyes closed, you remain within a spiral of light and gravity turning in silence. This awareness does not demand effort. It invites ease. If the universe can move for billions of years without strain, then a single mind can release its weight for a while. The stars are not tense. The clouds do not hurry. The arms do not compete. Everything follows its path. Let thought slow as the galaxy is slow. Let the sense of scale widen. You are not small in a hostile void. You are a local expression of a vast ordered system. The same forces that guide stars also hold you. Gravity binds. Time carries. Matter remembers. The Milky Way is not above you. It is around you. It is beneath you. It is within you. Every cell contains history written by stars. Every moment unfolds inside a structure older than Earth and calmer than any storm. To rest is not to fall away from the universe. It is to settle more deeply into it. The galaxy does not mark beginnings or endings. It moves through a continuum where every moment flows into the next, without ceremony. What feels like an ending on one world is only a transition within a larger rhythm. Stars fade, yet their atoms become seeds. Planets cool, yet their material joins new clouds. Even emptiness is only a pause before form. The Milky Way is a teacher of continuity. It shows that nothing truly disappears. It only changes state and position. Within this immense system, there is no central audience and no final goal. There is only motion shaped by simple laws repeated across time. Gravity draws. Energy flows. Matter organizes. From these basic actions, complexity arises. Arms curve. Suns ignite. Worlds assemble. Life emerges. Thought appears. All of this happens without intention, yet with coherence. The galaxy is not designed, yet it is ordered. It is not conscious, yet it gives rise to consciousness. To exist within such a structure is to be part of an ongoing experiment that began with the first stars. Every living being is a brief window through which the universe experiences itself. For a moment, atoms that once drifted in darkness can sense light and silence. They can wonder. They can remember. They can imagine what lies beyond their immediate horizon. This is not separate from the galaxy. It is the galaxy expressing itself in a new form. The scale of the Milky Way invites humility, but also belonging. You are not an intruder in a foreign universe. You are native to it. Your body obeys the same laws as stars. Your chemistry is galactic. Your existence is permitted by the same balances that hold spiral arms in place. There is no outside to this system. Every place is within. As the mind prepares to rest, it can release the illusion of isolation. The room is part of planet. The planet is part of a star. The star is part of an arm. The arm is part of a galaxy. The galaxy is part of a web of countless others. You are not alone in a small corner. You are embedded in a structure that spans light years and ages. The Milky Way will continue whether watched or not. It does not depend on memory. It does not require meaning. Yet meaning arises naturally within it. Every calm breath is a small echo of a larger rhythm. Every pause mirrors cosmic patience. There is no need to hurry within a universe that measures time in billions of years. Rest is not withdrawal from reality. It is alignment with it. The galaxy does not resist night. It turns through it. Clouds cool. Stars shine. Worlds rotate. Everything finds its place in darkness and light. In the same way, the mind can settle into stillness without fear. You remain held by the same forces that hold suns in their paths. The Milky Way is a home that does not close. It does not sleep, yet it allows sleep. It carries every world through space without demand. You are traveling with it now. Even in stillness you are moving. Even in silence you are part of a vast ongoing story written in stars. The Milky Way has no edge that can be felt from within. There is no wall where motion stops. Every direction leads deeper into structure, deeper into time. Even what we call empty space is filled with faint light, drifting particles and unseen mass. The galaxy is not a container with contents. It is a continuous field of motion where stars, clouds, and worlds are only temporary concentrations within a larger flow. In this flow, nothing is rushed. Orbits unfold over millions of years. Clouds gather for ages before collapsing. Stars burn patiently, converting mass into light at a steady pace. The galaxy demonstrates that endurance is not force, but balance. It does not push. It holds. It allows matter to follow its tendencies without resistance. This is why it lasts. This is why it remains coherent across billions of years. Human time is brief, yet it is not separate. A single lifetime is a tiny ripple in the same current that carries stars. The difference is only scale. The rules are the same. Change happens. Forms appear. Forms dissolve. Continuity persists. The galaxy is a reminder that existence does not require permanence to be meaningful. A moment is enough. A short life can still belong to an endless system. When the mind grows quiet, it can sense this belonging, not as an idea, but as a feeling of being held within something vast and stable. You do not need to visualize arms or stars. You only need to recognize that the ground beneath you is in motion with a structure older than any fear. You are already moving with it. You have always been. Every clear night is an invitation to remember this. The pale band across the sky is not decoration. It is orientation. It tells you where you are in the universe. It tells you that you are inside a rotating system of light, even when clouds hide it. The galaxy remains above you, around you, within you. The Milky Way does not speak in words. It speaks in duration. It teaches through scale. It shows that chaos can become order, and that order can remain gentle. It carries storms and silence within the same structure. It holds violence and calm without contradiction. It is large enough for both. As you let thought fade, there is nothing to solve. The galaxy does not ask for understanding to continue. It simply moves. You are free to move with it without effort. Sleep is not absence. It is participation in a deeper rhythm. While consciousness rests, atoms remain in motion. The body remains within the same cosmic flow. Somewhere in the disk, stars are being born. Somewhere in the halo, ancient suns are fading. Somewhere clouds are gathering for futures not yet imagined. All of this is happening now. And here, on one small world, a mind prepares to rest while traveling through space at extraordinary speed. You do not fall asleep in isolation. You fall asleep inside a galaxy. A structure of light and gravity carries you forward through darkness. It has done so since before you existed. It will continue long after. There is nothing to hold up, nothing to maintain. You are already supported by the same forces that hold spiral arms in place. The Milky Way turns. The universe expands. Time flows. And within this vast passage, you are allowed to be still. The Milky Way does not announce its presence with sound or motion that can be felt. It is revealed only through light and understanding. Yet it surrounds you more completely than any wall or horizon. The ceiling above you is part of a planet. That planet is part of a star. That star is part of an arm. That arm is part of a galaxy that has been turning since long before the first cell appeared on Earth. You are not beneath the universe. You are within it. In the deepest sense, there is no separation between inner and outer. Thought arises from matter shaped by stars. Emotion is chemistry guided by the same forces that guide clouds. Even the idea of distance exists because light travels. Everything you experience is a local expression of a much larger order. The galaxy is not a backdrop. It is the environment in which all meaning becomes possible. There is a quiet dignity in this. You do not have to be large to belong to something immense. A single leaf belongs to a forest. A single wave belongs to an ocean. A single mind belongs to a galaxy. Scale does not remove connection. It strengthens it. The Milky Way is vast enough to hold endless variation and stable enough to let each part exist without strain. The universe does not demand urgency. Stars are not anxious about burning out. Clouds do not worry about collapsing. Orbits do not question their paths. Everything follows what it is. In that example, there is permission. You are allowed to be what you are without resistance. Rest is not failure. It is alignment with the natural pace of existence. Even when awareness fades, belonging remains. Sleep does not remove you from reality. It places you deeper within it. While the mind quiets, the body continues to orbit. While dreams form, the earth turns. While breath slows, the sun advances along its path. All of this happens together. There is no moment where you are not part of the same motion as stars. The Milky Way is not something you must reach. It is not somewhere else. It is already here. It is the context of every place you have ever been. It is the reason there is ground beneath you and light above you. It is the continuity that links every generation of matter from the first stars to whatever will come next. In that continuity, there is no need to hold tension. The galaxy does not collapse if one world rests. It does not dim if one mind sleeps. It carries billions of worlds at once. It can easily carry one more moment of quiet. Let the sense of vastness become gentle rather than overwhelming. It is not a reminder of insignificance. It is a reminder of inclusion. You are inside something that has endured for billions of years. You are moving with it now. There is nowhere else you need to be. The Milky Way turns in silence. Stars continue their patient burning. Clouds gather in darkness. Time flows without demand. Within this endless movement, you are free to pause. You are already where you belong.